Welcome to the Radicals test review. For this review, I'm going to pick and choose some problems. I will write the answers for the other ones, but for when it comes to purposes, I would like you not to just write the answer, but to actually work through the problem and to check your work. So, number one is the first one I'm just going to give you the answer to this so you can check it. The answer is 4 square root of 6. 4 times the square root of 6. All right, number two. So we're simplifying these radicals. To simplify, I'm going to look at the 6's on the outside. That's multiplication. What we're going to do is we're going to break down always with the radical first. So we're going to look at 200. So what two numbers multiply to 200? That's 2 times 100 is one of the ways. 2 is a prime number, so I'm going to circle that. 100 is 10 times 10. There's also other ones. 10 and 10 are not prime numbers. So I go 5 times 2 is 10. 5 times 2 is 10. And now what I'm going to do is I'm going to rewrite the 6 times the square root of 200. Instead of 200, I'm going to write 1, 2, 3 2's and 2 5's. And this will be, and it's a square root, so we're looking for pairs. So we have a pair of 2's and a pair of 5's. The reason why I'm looking for pairs is, so the 6 is going to be outside. 2 times 2 is 4, and the square root of 4 is 2. So that's why we write a 2 on the outside in front of the square root. It no longer is a square root. And then we have 5 times 5 is 25, and the square root of 25 is 5. So there you notice there's no square root there anymore. Now what's left is just the 2 underneath the square root. And then to simplify this a little further, we multiply the numbers on the outside. 6 times 2 is 12, times 5 is 60. So 60 times the square root of 2 is your final answer. All right, number 3, this is a cube root, so I'm going to work through this problem also. So there's no numbers on the outside. You can always put a 1 on the outside if you'd like. Not needed. 250 breaks down, easiest way that I know is 25 and 10. 25 is 5 times 5. 10 is 5 times 2. So we have a cube root. So the little 3 in this little check mark area, that's the index. That's telling us that we need groups of 3. So we have 1, 2, 3 5's and a 2. So we need groups of 3. Well, we have one group of 3. And really 5 times 5 times 5 is 125. And the cube root of 125 is 5. So cube root, you need groups of 3. And there's 2 left over, and then we have no multiplication on the outside to put together, nothing on the inside. So that's our final answer. It's 5 cube root of 3. Number 4. So this one, I'm going to write down just the answer, and that's a negative 12 cube root of 5. Number 5, your answer is going to be 20 x to the third a squared square root of 2a. That's your final answer. Number 6, final answer, we have, well, I'll just do it. So 2 can't be broke down. 2 and 1, that's a prime number. If we have 3, I should back up. We have a square root of 2 and a square root of 2. When you're adding and subtracting, that's what tells you if they're like terms or not, is the radicals are the same, so they're both square roots, and what's underneath the radical is the same. If there were variables, those would be included. All has to be exactly the same. Variables, exponents, numbers, the coefficients, everything. Not the coefficients, my bad, just the numbers underneath. Now we have 3 square roots of 2, and we're subtracting 1. Well, what's left is 2 square roots of 2. There are 2 left. All right, number 7. Now we're going to be adding and subtracting. Whenever you're adding and subtracting, your first thing is to simplify each individual radical. So each individual one. So I'm going to break down 72, and I'm just going to think 9 times 8, 3 times 3. Those are your prime numbers. 4 times 2 is 8. 2 is a prime number. 2 times 2 is 4. So the square root of 72 gets broke down into 2 times 2 times 2 times 3 times 3. It's a square root, so we need groups of 2. So 2 will come out, pair of 3's, and what stays underneath is the 2. So 2 times 3 is 6, square root of 2. So that's our first term. Second term, we have 50 is 25 and 2, and 5 and 5. So we have 3 times the square root of 2 times 5 times 5. It's a square root, so we need groups of 2, so that 5 times 5 is 25, and the square root of 25 is 5. So we have the 3 comes down, times 5, square root of 2. And that's 15. 3 times 5 is 15, square root of 2. And then we have the subtraction comes down. And then lastly, we have 98 is 49 and 2. 7 and 7, those are prime numbers. So this is going to be 2 times 7 times 7. And pairs, square root of 7. So that'll come down as 7 square root of 2. Nothing to simplify there, so it'll just be 7 square root of 2. Now we gotta look at like terms. So we have square root of 2. That's also a square root of 2. And so is the last one. So they're all like terms. So we now are combining our coefficients. So we have 6 square roots of 2, and we had 15, so that's 21 square roots of 2 minus 7. So that's going to be 14 square roots of 2. And there's your final answer. All right, number 8. Now we have multiplication. Multiplication means now we're going to do a different set of rules. Here you multiply first, and you would multiply numbers on the outside if there are any numbers. So we do 1 times 1. It's really not needed for this because 1 times 1 is 1. I'm just doing it for purposes of, so you can see if there are coefficients in front, you would multiply those. And then you also multiply the numbers underneath the radicals. So 18 times 6 is 108, 108. And now we break that down into, let's see, 54 and 2. And that's 9 and, whoa, that's a weird looking 9. 9 and 6, 3 and 3. 6 is 3 and 2. And then that breaks down. We have a 1 on the outside. You don't actually need the 1. We have 2 times 2 times 1. There are 3 3's. Pair of 2's comes out. So you can have that 1 on the outside if you'd like. 2 times 2 is 4, and square root of 4 is 2. So that's why I have a 2 on the outside. Pair of 3's. Does not matter which one you circle. And then there's a 3 left over on the inside. So we have 1 times 2 times 3 is 6. And then square root of 3. Alright, I'm going to do number 9. So here we have multiplication. And this is distributing. We're distributing this one term times the binomial, both the terms on the inside. We have 2 terms here. And you can actually include, a lot of times I include that subtraction with it. So you're going to do negative 7 square root of 10 times the square root of 10 first. And then you're also going to distribute the negative 7 square root of 10 times negative 4 square root of 15. So just like number 8, we're going to do each one separately. The top problem, we have on the outside, negative 1 times 7 is negative 7. And then on the inside, 10 times 10. I'll just continue with this. You actually don't even need to break it down to perfect squares. I mean prime numbers. If you ever have a pair, you can circle it in square roots. So 10 times 10 is 100, and the square root of 100 is 10. So that's going to be a negative 70 for our first term when we distribute. So our answer is going to be negative 70. And now we're going to work on the second one. We have on the outside negative 7 times negative 4 is positive 28. And on the inside we have 10 times 15. 10 times 15. And that's going to be, this one's going to take a little longer to simplify. So that's 150. Breaking that down, 10, 15. I actually had students ask, do we really have to multiply it together? Can't we just break it down over here? Sure. Absolutely you can. So this is going to end up being 28. We have 2 times 3 times 5 times 5. So we have a pair of 5s that'll come out. That's just 1 5. So 28 times 5. 2 times 3 is left over on the inside, which is 6. And 28 times 5 is 140. Oh yeah, 140. So we have, wait a second, I missed a, no, I didn't miss a negative. So that'll be positive. So positive 140 square root of 6. Now, we're going to want to put these numbers together. But you cannot, because we have multiplication, this multiplication here, and with the math rules, order of operations, you have to do multiplication prior to doing addition. So we cannot do that. We cannot combine those. They are not like terms. So that is our final answer. All right, number 10, the answer there on number 10 is 5 square root of 21 minus 12 square root of 14. Number 11, answer is negative 6 plus 2 square root of 3 minus 3 square root of 2 plus the square root of 6. And number 12, I'm going to work out with you. So this square means base times itself. So this really means square root of 3 plus the square root of 5 times the square root of 3 plus the square root of 5. So what I'm going to do here, because we have 1, 2, so binomial times a binomial, 2 terms times 2 terms, I'm actually going to kind of set it up as a Punnett square. And this is going to hopefully organize things a little bit nicer for us. So we have 2 terms, so I'm going to have 2 columns, and by times 2 terms, so I'm going to have 2 rows. So I have the square root of 3 plus the square root of 5, and another square root of 3 plus the square root of 5. So I'm writing one of the binomials horizontally up top, and one of the binomials vertically on the side. And now I'm going to multiply, so I have the square root of 3 times the square root of 3, which that is the square root of 9. Then I have the square root of 3 times the square root of 5, and that's multiply underneath. That's going to be the square root of 15. Then I'm going to do the square root of 5 times the square root of 3. It really doesn't matter the order you write these in, multiply these in. I'll multiply underneath the square root, so 3 times 5 is 15. And lastly, I have the square root of 5 times the square root of 5, so 5 times 5 is 25. After you multiply radicals, you always look to simplify. So we're going to look inside to see if there's anything we can simplify here. And so we have square root of 9, that's 3. So I'm just going to do a quick little Punnett square. So the square root of 9 is 3. The square root of 25 is 5. And here's the kind of cool thing. A lot of times you'll have like terms diagonally, and you always, always, always add them. Always add them. So we have 1 square root of 15, and we're adding another square root of 15. So that's going to be 2 square root of 15. So we have 3 plus 5 is 8. Plus 2 square root of 15, and that's our final answer. You can look this breakdown. I should say square root of 15 is 5 times 3, and those are not, there's no pairs there, so there's nothing to simplify. Number 13 is very similar to number 12. The final answer there is 38 minus 16 square root of 3. Number 14, again, very similar, negative 12 minus 10 square root of 3. And number 15, you're going to simplify each individual radical. So 9 square root of 6, can you break it down? 2 times 3. Can you simplify anything? No. So we want to identify the radicals in simplest form, meaning you cannot break it down. So yep, that's one of the answers. We have 5 square root of 6x cubed. 6 is 2 times 3, so no, but here's x cubed. We have x times x times x, and there's a pair. So that can be simplified, so that is not in simplest form. Next one, square root of 60x. Can that be broke down? 6 times 10, yeah. 2 times 3, so far we don't have pairs. Oh, here we go. The pair of 2's, so that can be broke down, so that is not in simplest form. And then the last one, 34xyz. 34xyz. 34 is 17 and 2, and 17 can't be broke down. That's prime. X is 1, Y is 1, Z is 1, so it's all just 1s, so there's nothing there that I can break down any further, so that for it is in simplest form. So just those two. On number 16, the two that you're going to find that are in simplest form are none of them. None of them are in simplest. Oh wait, no, just kidding. Top left is the only one that's in simplest form.